Okay, so like I said, as long as you multiply or divide the top and the bottom by the same number. Okay, so for example, if I have 1/2, if I decide to multiply both the top and the bottom by 5, I'm going to get 5/10. Well, 1/2 and 5/10 are equal. Remember when we had the pizza pictures? 1, 2, 3. 10. Okay, so pretend these are all the same size. If I have half of them, 1/2 of the pizza is also 5/10 of the pizza. It's the same amount of space, it's just different size pieces. Okay, and we can go the other direction. Let's say I have 6/10, and I want to simplify, which is the same thing as reduce. So I can divide both by 2, and that's going to be equivalent to 3/5. Okay, I can divide both of these by 17, which is going to give me 5 and 3. Because I knew I could divide this by 5 because it ends in a 5, and I knew I could divide this by 3 because it adds up to 6, and both of those gave me 17. But this repeated division may be also not the best way to go. Remember how I said factor trees are really useful? I'm going to make a factor tree. It is, but it's a different way to look at it. When I make a factor tree, that tells me that this fraction factors into 2 times 5 times 17 over 2 times 3 times 17. Still negative. And any numbers that match between the numerator and the denominator, they're going to cancel. So what I'm left with is negative 5/3. So again, I can do repeated division. If that's easier, you can do it that way. Or you can make 2 factor trees. List your factors, and your matching factors between numerators and denominators cancel, and you can simplify that way. Okay, 45 and 81 will both divide by 'em. If you didn't want to do it that way, if you wanted to do the factor tree method, and this is a good example because it'll tell me what happens when I have things that don't cancel, but not just one. So 45 is 3 times 3 times 5. And 81 is 3 times 3 times 3 times 3. Well, 3's cancel and 3's cancel. So I'm left with 5 over 3 times 3. So anything that's left over, you multiply back together. Okay, the greatest common factor is the largest number that will divide evenly into 2 numbers. Okay, so we're looking for the biggest number that goes into those numbers, not the biggest number that those numbers go into. Does that make sense? So we want something that fits inside the numbers we're looking at. Okay. The best way I know of to find greatest common factors, factor trees.
But we have three of them. We have three
You do
numbers.
factor tree on all three.
Take a long time.
Let's say I have 24 and, no, because that's 24 times 3. Okay. This is 2 times 12, 2 times 6, 2 times 3, 2 times 28, 2 times 14, 2 times 7. What I need to do is I need to find the matching pairs between the two numbers and write one of them down. So I have one pair of 2s, and then I have another pair of 2s, and another pair of 2s. So for each pair, I write down one number. If I multiply those together, this is my greatest common factor. This 3 and the 7 that were left over, we just ignore those because those are not a factor of both numbers. If I have 3 numbers and I want to find the greatest common factor, I'm going to factor all 3. Oh, that's not 5 times 25. 21, sorry. Okay. Instead of pairs though, because I have 3 numbers, I'm going to look for triplets. So I have a 3, and a 3. I have a 2, and a 2. And then I have a 5, and a 5.
So 5 times what? On the 1 5, what is that?
5 times 21. So that would be 30. So however many numbers you are trying to find the greatest common factor of altogether is how many you need to have it in a row. So like if it's 2 numbers, you look for pairs. If it's 3 numbers, you look for triples. If it's 4 numbers, you need a quartet, etc. Does everybody have this? Right. Let's go back to these numbers here. I had 24 and 56. So let's say I put 24 over 56. Well, we factored 24. And we factored 56. And you remember those pairs we were talking about? If we're using greatest common factor to simplify fractions, everything that is a pair is going to cancel each other out. And whatever is left over 24 has a 3 left over, 56 has a 7 left over. Or we could say that the greatest common factor was 8. We found that already. And we can divide both of them by 8. So 2 methods using the greatest common factor. One, we can do all of the pairing. It's just that every pair cancels each other out.
So there's 3 7s.
Mm-hmm. So every pair cancels each other out and you're left with a 3 and a 7, or you can say the greatest common factor was 8, so you divide the top and the bottom by 8.
Wait,
If we're simplifying by tens, hundreds, thousands, etc., anytime you have fractions that have zeros in the numerator and the denominator, the most beautiful thing happens. Zeros cancel each other out. Isn't that nice? They just cancel each other out. So I can reduce this giant fraction without doing any math, right? Well, I can start to anyway. All the zeros are going to cancel each other out that matching zeros. So this is going to be 25 over 7,500. Now I'm going to have to reduce this some more because 25 will go into 7,500.
5 and 25.
Okay, if I divide 25 by 25, I get 1. If I divide 75 by 25, I get 3, and then I have 2 zeros that are still hanging out. But I got rid of all these extra zeros, and that made it easier, right? You take all those extra zeros away, and that makes it easier. You know, 800 over 2,000, cancel one set of zeros, cancel the other, and I have 8 over 20. This is easier to deal with. Yeah, I could divide by 2 if I wanted to, do repeated, and I'll get 4 and 10, which I can then divide by 2, and I get 2/5. Or maybe I saw from the beginning and I divided by 4 and went straight to 2/5. But 8 over 20 is nicer to deal with than 800 over 2,000. So beautiful thing about extra zeros on the numerator and the denominator, if you have a 0 on top and 0 on bottom, they cancel each other out. Easy reducing method. So 10 is 2 times 5 times x times y. And 6 is 2 times 3 and then times x. And then you cancel everything that matches. Okay. The 2's match and the x's match. I have left 5y and 3.
Okay, what do we have about the X one?
So same problem. I'm going to do, so that you can see the comparison. Is first you're going to separate by type. Okay, so numbers together, x's together. There's only one y, so I'm just going to put a 1 underneath it. And then you reduce each part. So 10 over 6 will both divide by 2. X divided by x is 1. And then that y is just by itself. And then you multiply them back together.
What is that? Third and one?
Yeah.
Why can't you write it just as a y?
Oh, you could, but I put it on top because you're gonna need to keep it on top. So, it's, you don't really actually, okay, so 5y over 3 is the same thing as 5/3 y. They're the same thing. So if it's easier for you to just write it as a y, that's okay. Just remember it looks like this. It doesn't go in the denominator. It either has to stay on top or it has to be like independent.
And this is just a different way of doing it.
Yeah, this is just a different way of doing the same exact problem.
And then you'll be canceling the number, right?
Hmm?
You put y, and then you be
No,
canceling.
it's a y over 1. She meant why can't you just say times y with nothing else there? Which you can do. You can do that. Just be sure not to stick it then in the denominator.
Yeah,
Because
then
it,
you'll cancel out and you won't have one.
yeah. So, this is just another method. I would say most people like method 1 better, but some people like method 2 better. It's just two different ways to look at it. Now, method
Can you use
3 is to just look at it all together like this and say, okay, 10 and 6 both divide by 2, and then the x's are going to cancel.
that? Well, that's what it is.
So if you're, if this is something that you can do, then you can do it all in one piece. You don't have to split it all up, but that's, again, everybody's brain works differently, so everybody's going to feel more comfortable with something different as far as these go, but there's more than one way to do it. So pick the way that makes the most sense to you and use that one because it's all the same. I'm going to start by expanding. Okay, 2 is just 2, and then a to the third is a times a times a. 4 is 2 times 2, and a to the fourth is a times a times a times a. So I expanded it all out. 2's cancel, 1 set of a's, 2 sets of a's, and then 3 sets of a's cancel. See how I have nothing left up top? I had to put a 1 up there.
2/4 is half to begin with, right?
Uh-huh, exactly. So this is method 1, that's the expansion method. Okay, the other way I can look at it is I can look at the 2/4, and then I can look at the a's. Okay. 2/4 is going to reduce to 1/2 because I can divide them both by 2. When you have division, you subtract the exponents, and whatever side the larger exponent was on is the side that your answer goes on. Okay, so an example of what I mean by this, just if I have a to the 5th, actually let me use x so that it's not confused with the actual problem we're doing. Let's say I have x to the 5th over x squared. 5 minus 2 is 3, right? So that's going to be x to the 3rd. But if I have x squared over x to the 5th, 5 minus 2 is still 3, but because the 5th was in the denominator, the 3rd goes in the denominator. So it's on the same side as the bigger exponent. Does that make sense? Okay. Yeah, so here I have x to the 5th over x squared, right? So I do 5 minus 2, and that gives me 3. Because of this.
Oh, the cancel.
They're canceling, yeah. So I do 5 minus 2, and that gives me 3. Because 5 was up top, the 3 is up top. But if I had 2 over 5, it's still 3, but because the 5 was in the bottom, the 3 is in the bottom. So it's kind of like a tug of war between the numerator and the denominator, and the bigger exponent is the bigger muscle to pull it to that side. Does that make sense? To expand, I'm going to do 2 times 5 times x times y, 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 and then z, z. And then on the bottom, I'm going to have 2 times x times x times x times y times z times z. Okay, so that's expanded. My pairs that I'm going to cancel. And what I'm left with is 5, 1, 2, 3, 4 y's over x. Or I can write that as 5y to the 4th over x. Now you can see the expanding can get to be kind of annoying if you have a lot of exponents, right? So what I'm going to do instead is I'm going to look at each of these in parts. 10 divided by 2. 3 minus 2 is 1, but because the 3 is larger, my 1 is going to go in the bottom. 5 minus 1 is 4, and then 2 minus 2 is 0, so it goes away. Yeah, so I did 10 divided by 2, which gives me the 5. I have the x's. I have 3 minus 2, which gives me a 1. But because the 3 was bigger and it was in the denominator, that's where the x goes. And then I had 5 minus 1, which gives me 4. 5's on top, so that's where the 4 goes. And then 2 minus 2 gives me 0, which means I don't have any left. So it goes away.
5y 4 over x.
Mm-hmm. Expand this one. I'm just separating it into its parts, so it's easier to look at. Okay, so if I'm reducing 4 over 18, they both divide by 2. So I'm going to get 2 over 9. Here I'm subtracting 3 minus 2, but that 3 is bigger, so I'm going to get x on top. You don't have to put the 1 there if you don't want to. You just make sure your x is on top. And then I have 10 minus, or 12 minus 10. The 12 wins, so it's y2, but it's in the bottom. And then I have 4 minus 3, or sorry, 4 minus 1, which is 3. With the exponents on the z's. So you just look at each part individually. Don't like look at that whole big thing and go, oh my gosh, it's so much stuff. Just look at each little matching piece.
Where do these ones keep from?
Then we, to placeholders, and then we put it all together.
Yeah.
It's very difficult. Multiply A times C and multiply B times D. And then reduce. Okay, I'm going to multiply 2 times 4, and I'm going to multiply 5 times 7, and I'm going to get 8 over 35. Doesn't reduce, I'm done. You cannot multiply mixed numbers. There is no formula or pattern to do that, to take like 2.5 and multiply it by 3 1/4. I've seen people multiply the whole number parts and then multiply the fraction parts and been like, here you go. No. No, 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 no. Very bad. You'll go to fraction timeout. If I want to multiply this,
Like 2 times 4 and then put it on top.
yep, I have to do 2 times 4 plus 1. And so that becomes 9/4 times, multiply and add 7/2. Then I can multiply it.
So y'all would keep the bottom denominator.
Yeah, you keep the denominator the same when you're converting from a mixed number to an improper fraction. But you have to, anytime you have a mixed number and you're dealing with multiplication or division, you have to convert them to improper first. And if you're doing on my paper, like a paper test for me or whatever, just leave it like this, I don't care. Improper fractions are fine as long as it doesn't reduce. If you're required to turn it back into a mixed number, you have to say, okay, 8 goes into 63 7 times, which would be 56, with 7 left over. But like I said, this answer is perfectly acceptable to me.
But not to the test.
No, on my tests.
Yeah, well, only to you. Not to anybody else.
She's the one.
Method 1. Okay, first, fractions follow the same rules of positives and negatives as integers. So a negative times a negative is going to be positive. So I'm going to multiply 10 times 21, so I'm going to get 210. And I'm going to multiply 18 times 55, which is going to be in here. Oh, wow. I can't even see what I'm doing. Okay, and then I have to reduce. Well, they'll both reduce with the zeros, right? So it gives me 21 over 99, which will both reduce by 3. So I'll get 7 over 33. Or you can reduce first. It's called cross-canceling. What I do is I look at the numbers that are across from each other. 18 and 21 will both divide by 3. 3 goes into 18 6 times. 3 goes into 21 7 times. And then I look at 10 and 55. These will both divide by 5. That's 11. And this is 2.
You gotta keep the sign rather than.
Yeah, you keep the signs. Now look at this though. Now I have 2 over 6. What I've now got is I've got negative 2 over 6 times negative 7 over 11. But 2 and 6 are both even.
Can you read those?
So I'll reduce those. So you can reduce inside your fraction and you can reduce by cross-canceling. Then I can multiply. So I'm actually, when you do the cross-canceling, you're reducing smaller numbers. So sometimes it's not as cumbersome. But again, matter of preference, I get the same answer. So it's up to you. Okay, so now I have 90 over 450. Zeros will cancel, so it gives me negative 9 over 45. These will both divide by 9. So I'm left with -1/5. Okay, so that's the multiply, reduce. Okay, method 2. Okay, 6 and 18 will both divide by 3, right? No, sorry, they'll both divide by 6. So 18 divided by 6 is 3, and 6 divided by 6 is 1. And 15 and 25 by 5, so that gives me 3 and 5. So my new fractions are -1/5 and 3/3. What's 3/3 reduced to? 1. So that's -1/5 times 1, or just -1/5. So this was reduce and then multiply. I can use both methods here as well. Okay, I can multiply straight across. 5x times 2 is 10x. 7 times 15x is 95? Yes, okay, 105. 105x. Now when I reduce this, the x's will cancel. So I have 10 over 105, and these will both divide by 5. So I get 2 over 21. Okay. Or if I want, I can do the cross canceling. 7 and 2 won't cancel, right? You guys agree? Okay. But 5 and 15 will. And so will the x's. And so I'm left with 1/7 times 2/3. So I get 2 over 21. Method 1, I'm going to multiply straight across. So 2a squared times b to the third. That's just 2a squared b to the third. And then I have 3b times a. Well, that's 3ba, but I'm going to rewrite it as 3ab so that it's alphabetical, because that makes me more comfortable. Okay. Then I'm going to reduce each section. 2 and 3 don't reduce. I have a squared over a, so I'm going to subtract 2 minus 1. It's 1, and it's on top because the a is bigger. And I'm going to do the same thing here, b to the third minus, or over b. That's 3 minus 1, which is 2, and the 3 is on top, so it stays up top. Now with cross canceling, here's how it works. I have 1b here and 3 b's up here. Do you see that? 1b, 3 b's. I'm going to take one of these b's and one of those b's. So I took 1b away from the bottom and I took 1b away from the top. I'll do the same thing with the a's. I have 1a down here and 2 a's up here. I'm going to take away 1, and that'll leave me with 1. So then what I have now is 2a over 3 times b squared over 1, because that a went away, so we put the 1 in as the placeholder. And then I multiply them together. So if you cross cancel with exponents, you do your subtraction again. If I have 1b here and I had 3 here, I take 1 away from each, so now there's 2. If, for example, we're just going to do like something like this, and I'm cross-canceling, I have 4 x's and 6 x's, so I would take 4 away from here, I would take 4 away from there as well. So you take the same number away from each side on the of the cross. Does that make sense? Just the same, like if I had, right, if I have 2 here and 5 there, I'm going to take away 2 from here, I'll take away 2 from there. Well, I can do this 2 ways. I can multiply these 2 numbers together and then multiply it by half. Or I can multiply half by 6 and then multiply that by 4. Because multiplication doesn't matter. Any preferences?
Can you divide it by 2?
Or you can divide it by 2. Which, when you multiply a fraction times a whole number, numerators multiply and denominators divide. And this is when you do fraction times a whole number. Okay. I divide 2 into 24. And it'll go 12 times. Right? 2 into 24 is 12. This was division. And then I multiply 1 times 12. Which is 12.
You just take that number and split it in half, like that,
Right, but what if I'm multiplying by 2/3? So, everybody got this? Going to give you another example of multiplying a whole number by a fraction real quick. And then we'll come back to the triangles. Okay, so 2/3 times 15. 3 goes into 15 5 times. 2 times 5 is 10. What if I have a situation like this? 3 does not go into 7. Then I just do my multiplication and I carry them over my denominator. So this is how you deal with fractions and whole numbers. If the whole number will divide by the denominator, do that first, and then multiply by the numerator. If it won't divide, 7 does not divide by 3, then you multiply by the numerator, and then you just keep the denominator the same. Because technically, what you're doing at this point is doing that. You're putting a 1 in the denominator. This is technically, you're turning this 7 into a fraction by putting a 1 in the denominator. But you don't actually have to write this step out.
So how does it equal 10? Because there's a, I don't understand that.
Numerators are multiplication. 2 times 5 is 10. So you divide by the denominator and then multiply by the numerator. That's for this first one. But if the denominator doesn't divide, you multiply by the numerator and then carry the denominator.
Can you just also put a division sign and put a 1 in the bottom?
Not division, multiplication.
So
Yeah.
whatever you would divide by, you multiply the top by, correct?
Multiply by the top, divide by the bottom.
Right, like on the top one, you use divided.
3 into 15 is 5,
Right.
and then I did 2 times 5 to get 10. Okay. What happens if I have fractions with fractions with fractions? Okay. Ready?
You multiply,
Huh? Yeah.
cancel them, and then multiply, cross multiply.
I'm gonna do a pretty triangle. It's gonna be like this. And my height is gonna be 3/4. And my base, terrible triangle drawer, is gonna be 5/3. And my area is still gonna be 1/2 the base times the height. Okay. My base is 5/3 and my height is 3/4. So I'm gonna look at 1/2 and 5/3. Nothing is gonna cross cancel here. And if I look at 5/4 and, or 5/3 and 3/4, my 3's can cancel, right? Cross cancel? If we like cross canceling, we can cross cancel those. They both divide by 3. If we don't like cross canceling, we can multiply across the top. 1 times 5 is 5, times 3 is 15. And then you multiply across the bottom. 2 times 3 is 6, times 4 is 24. So you just multiply straight across. And then these will both divide by 3, which will give me 5/8. Or like I said, if you'd like to cross cancel, I can cross cancel first, and I do 1 times 5 times 1 and 2 times 1 times 4. So 1 times 5 is 5 times 1 is 5. 2 times 1 is 2 times 4 is 8. So even if you have a long string of fractions, you multiply across the top and bottom.
So is A equals 5/8?
And it's square feet because it's area.